Evaluate using the remainder theorem at x equals 5. Another way that might be written is saying f of 5. These would be the same thing. It's just telling you that you need to do synthetic division with a 5 into this polynomial. Before you write it out, make sure that you're not missing anything that you're going to have to fill in with a 0. So we've got an x to the 4th, an x cubed, x squared, x, and our constant. Nothing is missing, so we're not going to have any zeros. So we can just fill in our coefficients. 1, -3, -10, 3, -11. And then do your synthetic division, and your remainder is what you would get if you were to plug in 5. The remainder is the output. So do the synthetic division. 1, 5, 2, multiply, you get 10. Add, multiply, you get 0. Add, you get 3. 15. Add, you get 4. The remainder is the answer. So f of 5 equals 4, and that's it. This question comes from Bellwork 1. It's number 3. Determine the restrictions on the domain of f inverse. Key to this is making sure that you read the f inverse. Not the domain of f, it's the domain of f inverse. So, the domain of the inverse is the same as the range of the original function. And then the range of the original function comes simply from the coefficient of x, which is 1 over 1. So that would be where our horizontal asymptote is, which means that it is not in the range. So 1 is not in the range. Our range of f would be everything except 1. So it would be negative infinity to 1, union 1 to infinity. And the range of f is the domain of f inverse, so it's everything except 1. Everything except 1 is d. X cannot equal 1. Now from Bellwork number 3, question 2. In order to solve this, you need to get a common denominator and then solve. And then make sure you check for extraneous solutions. So the common denominator here would be x squared minus 9, which you get by multiplying x minus 3 and x plus 3 together. So this equation, in order to have a common denominator, needs to be multiplied by x plus 3. This one needs to be multiplied by x minus 3. And this one has the common denominator already, so we're good to go. Once you have common denominators, they cancel out. You don't need them anymore. You're clearing out the fractions. So this is negative 5 times x plus 3. So negative 5x minus 15. This is positive 8 times x plus 3, which is positive 8x minus 24 equals negative 30. Now, what you're going to find when we solve this out is we're going to have some answers involving 3s and 7s, and we're going to check for extraneous. So we'll finish it real quick. You get 3x. You add the 24 over, you get negative 6. Now, if you add the 15 over, you get 9. So x equals 3. So clearly it's not those because that's not the answer we got. If it's extraneous, though, we would have no solution. If we plug in 3, we can't, because we get 3 minus 3 is 0, and you can't divide by 0, so it would be extraneous. You cannot get a 0 in the denominator. So that means it's no solution. Even though you get an answer of 3, it is extraneous. So what you could have done right off the bat, you could have plugged in negative 3, and you would have found that that can't work because you have a denominator of 0. You plug in positive 3, that doesn't work, you'd have a denominator of 0. Negative 7 wouldn't work because that's not even the answer we got. So therefore, it's got to be no solution because none of those answers work. So you can always kind of work these problems backwards with the answers they give and see what works. But if you solve it out, make sure you get extraneous, check for extraneous, so you don't mess up. On bell work number 3, question 4, you got to find which one is a factor. So if it is a factor, that means that it divides in evenly. So you could factor this if it was factorable. It's not. Because it's 4 terms, you could check for factoring by grouping, but it's not able to be factored by grouping. So the best way to go here is just check to see what is an actual factor. So do synthetic division. You could do it with all 4 of them. But if you check x plus 2, that means you're doing synthetic division by -2 into 1, 6, 7, and 10. Again, make sure that you're not missing any powers, so you need zeros when you're doing synthetic division. So that's 1, -2, 4, -8, -1, 2. We got 12. We did not get 0, which means that is not a factor. You need a remainder of 0 to get for it to be a factor. So start over. You can try it now with b, which is +2, which, since all of these that we're dividing into are positive, and then synthetic division is just multiplying and adding, you'll see that there's no way this could work out, because since they're all positives, our numbers just keep getting bigger. You can't get a 0 unless there's a negative involved in the problem. So now, clearly that's not going to be a 0. That's 46, 56. Doesn't work out. Not a 0 because there has to be a negative involved somewhere. There's no negatives in the problem, so it's not it. For that same reason, we can eliminate option C, because when we put a +5 out front, again, there's no negatives involved. You can't get a 0 unless you have a negative. You have to have a positive something and a negative same number in order to get a 0. And that can't happen because you're not going to get a negative. So it's not B and it's not C. We'll check with the -5 just to make sure. 1, -5, 1, -5, 2, -10. We got a 0. That's our factor. So we're done. So from bell work 3, number 5, to find the x-intercept, that means you're setting it equal to 0. Your y equals 0 for the x-intercept. So really, you're just looking at the numerator in that case, because the denominator can't equal 0. So 0 equals 2x minus 1. Add the 1, divide by 2, you get 1/2, not 2. So no, that is not the intercept. It's false. You get the y-intercept. You plug in 0 for the x's. So you have 0 minus 1, 0 minus 2. -1 over -2 is +1/2. Yes, that is the y-intercept. For the vertical asymptote, you look at the denominator equals 0. So x minus 2 equals 0. X equals 2. Yes, that's the vertical asymptote. And for the horizontal asymptote, you look at coefficients in front of the x. 2 over 1, that's 2. So yes, that's the horizontal asymptote. So 2, 3, and 4, C. So bell work number 4 now, question 1. A negative in front of the function will flip it over the x-axis. If it's on the x, if it's negative on the x, it goes over the y-axis. If it's in front of the function, it goes over the x-axis. So the negative in front flips it over the x-axis. And then since that's a 1/5, that's a shrink, a vertical shrink. So shrink, x-axis, that is B. Bell work 4, question 2. We have log base 8 of x, log base 8, 3x plus 25 equals log base 8 of 18. Since they're all logs of the same base, we're going to combine them so we can solve this. We'll condense our 2 logs here. make that be log base 8. And then since it's addition, we condense it to be multiplication. Equals log base 8 of 18. Now, since we have the same log on both sides, and that's all we've got, the logs can cancel out. So this is 3x squared plus 25x equals 18. Move the 18 over so we can factor this. Now to factor, I like to do the bottoms up where you multiply the front to the back. So 3 times negative 18 is negative 54. So we're looking for numbers that multiply to be negative 54 and add to be 25. That would be 27 and 2. And to be a positive 25, it would have to be a positive 27 and a negative 2. But the bottoms up trick is that there's a 3 in front, so now you have to divide by 3. If it reduces, reduce it. So this is x plus 9. If it doesn't reduce, then you bring the bottom up. 3x minus 2. So if you go back and check, that does work out. X times 3x is 3x squared. 9 times negative 2 is negative 18. And the multiplication, or the addition, would work out for 25 also. So set that equal to 0, solve it out. You get x equals negative 9. And 3x equals 2. So x equals 2/3. Since these were logs, we need to go back and check for extraneous. You are not allowed to have a negative inside the logarithm. So plug in negative 9. Let's see what happens. We have log base 8 of negative 9. Not allowed to have negatives inside logs. So that's extraneous. X equals 2/3. That's okay there. It's not a negative. 2/3, that'd be 27. That's okay. That works out. So the 2/3 is okay. The negative 9 was extraneous.